Hello students, welcome to EPG Pathshala. I am Professor Dr. Sujit Bhattacharya, Professor in the Academy of Scientific Research and Innovation ACSIR and Senior Principal Scientist in CSIR NISTADS. Along with me, this module is co-authored by Shilpa, who is Research Fellow in CSIR NISTADS and Research Scholar in ACSIR. This module name is Science Indicators. This comes under the paper Informatics and Scientometrics. In this module, we discuss the concept of indicators. We talk about different science and technology indicators and their application, and we discuss mainly the output indicators of science and technology. Demonstrate how scientometrics and bibliometrics helps to construct S&T output indicators and apply them for capturing the different facets of science and technology. We give examples for highlighting the usage of some of the S&T indicators. The basic objective would be to understand indicators in general and SAT indicators in particular. Apply indicators for measuring some facets of scientific activity. In this slide, we discuss the construction of indicators. We have to understand two important concepts in this: construct and dimension. Construct is an entity that cannot be directly measured, such as creativity, performance, intelligence. As you can see that we cannot directly measure them, unlike variables such as weight, blood pressure and temperature that can be measured on a scale. Thus, we have to apply indicators for measuring these constructs. Constructs are composed of various dimensions. Indicators measure important dimensions. They act as proxy for this measurement. For example, financial indicators can show the health of a country's economy. Science and technology indicators helps to capture various facets, characteristics of science and technology, such as productivity, collaboration, impact. Productivity, collaboration, impact here are dimension of science and technology, and each dimension of it is measured through indicators. We examine the construction of an ideal indicator. An indicator ideally should convey information about a particular element or sub-element that it represents. For this, indicator should be representative, reliable, valid and feasible. There are two issues of primary importance: reliability. By reliability we mean consistency of measurement. That means each time we measure on a particular scale, the measurement should not vary. The other is the issue of validity. It is the accuracy of measurement. It is what we intend to measure, we are measuring. For example, take the case of research paper. It is through long research of scientometrics and bibliometrics, it has been shown that research papers are an ideal indicators to measure the research activity, primarily the output of research activity. So, it is a reliable indicator. But on the other hand, the question of validity comes if research papers are used to measure military research or research which has high commercial values, because in those the research paper is not the primary output. So, there the validity test is not really true, because there would be other indications by which the output comes. There are some of the important steps for measuring a construct through indicators. What we say is like this: subdivide the construct according to several set of dimensions. Dimensions we have already introduced in the earlier sections. Create indicators for measuring each of the dimensions, and creation of a composite indicators that captures all the dimensions. These three steps ideally leads to the construction of a set of indicators which are able to measure the construct properly. In this slide, we discuss science and technology indicators. Ideally, science and technology indicator should be able to describe the science and technology system. Science and technology system includes infrastructures like scientific manpower, laboratory infrastructure, journal, and various aspects of scientific activity. The indicators of S&T should enable better understanding of the structure of S&T system, impact of policies and programs, and the impact of science and technology on society and the economy. Science and technology indicators are constructed from various input and output statistics of the S&T system. The input indicators constructed from the financial statistics are level of funding for R&D, funding for basic or applied sciences. Example is JED, gross domestic expenditure on R&D, manpower involved in R&D. Output indicators are constructed from research papers, patents, standards, significant innovations, and product announcement. In this slide, we discuss the major R&D and innovation indicators, their strength and weaknesses. Financial indicator includes funding in R&D activities. It helps to capture how much investment is made in R&D overall by a country with respect to the country's total investment, can help us capture investment discipline wise, helps capture investment in priority areas. But the difficulty of using this indicator is that identify investment in S&T by source and by performance becomes difficult. Possibility of double counting can happen and thus inflate the statistics. The other indicator is of manpower indicator. It includes manpower involved in different activities of S&T. This helps to capture S&T personnel involved in S&T overall and in different activities. Again, the difficulty of this indicator is that it is difficult to capture the whole population involved. Overestimation can happen as well as underestimation of manpower involved in different S&T activities such as teaching. R&D can happen in this, but and does happen, but to the extent the R&D is happening during the teaching process is difficult to estimate. Another indicator is research papers. It acts as a good indication proxy to measure scientific research activity. But again, the problem is tacit and strategic knowledge cannot be captured through this indicator. In this, we discuss the common indicators of R&D. Further, we look at the indicators patents, standards, significant innovation surveys, expert judgment, and product announcements, and try to reveal their strength as well as we underscore their weaknesses of their applying for capturing R&D and innovation process. Patent is a legal document that gives the holder property rights to the invention. The patent as an indicator is useful because it provides indication of inventive activity which is novel and useful to the society, and also regular, detailed and long term data is available. The weakness of this indicator is that there is uneven propensity to patent across sectors. Standard is another indicator. A technology standard can be viewed as a set of specifications to which all elements of products, processes, formats, or procedures under its jurisdiction must conform. It is a good indication of adoption in technologies such as ICT, but again, standard is difficult to act and apply in capturing the adoption trend because of its long and complex documents which each standard specifies, as well as the large amount of scattering seen in these or in a standard of a particular technology or an area. Significant innovation is a direct measure of output. It helps to measure the innovation which has happened, but again the weakness is that cost of collection and misses incremental changes. Innovation service is a direct measure of output, and one can make it a very comprehensive through extensive survey. But the weakness is that variable definition of innovation makes one the question of reliability and validity as well as the cost involved in innovation surveys. Expert judgment uses direct use of expertise to say about the importance of innovation, but the weakness is of finding independent expertise, the pool of expertise, and also the judgment about given by expertise can be highly subjective. Product announcement. It is close to commercialization and thus acts as an important indicator of innovation. But the problem is that it misses in-house process innovations, misses incremental product improvements. In this module, we are discussing about the we now look at some of the indicators in more details. We look at input indicators, the two input indicators of financial indicators and manpower indicators. Financial indicators JUD shows the investment in R&D of a country with respect to the total investment. S&T investment per capita is another indicator frequently employed to highlight S&T priority. Share of R&D investment in different disciplines, areas of activity. Manpower indicator. One can construct various indicators of manpower. One is the total S&T personnel of a country is applied as an indication of the scientific capacity of a country. S&T personnel by their level of education further distinguishes the knowledge pool a country has. FTE, full-time equivalent, is used for showing actual involvement of person in R&D activities. This becomes important because in many activities of S&T, such as teaching or in library or other service related activities of S&T, the component of R&D involved has to be properly estimated. With proper estimation of that, one can get a correct estimate of R&D or manpower involved in S&T activities. S&T utilization ratio, which indicates how many S&T personnel are involved in a country or units with respect to the total population, salary of R&D personnel with respect to personnel involved in other activities. Friends, now we talk of what is scientometrics. Scientometrics is concerned with quantitative features and characteristics of science. It is a generic term for a system of knowledge which endeavors to study the scientific and technological system using a variety of quantitative approaches within the area of science and technology studies. Bibliometrics measures the output of scientific and technological activity. Bibliometrics, especially evaluative bibliometrics, uses counts of publications, patents, citations, and other potentially informative items to develop science and technology performance indicators. Bibliometrics largely overlaps with scientometrics and commonly they are used interchangeably. We attribute, or you can say make certain assumptions that about our scientometrics studies. These assumptions helps us to properly put the boundary and also helps to put the studies in proper perspectives. One of the thing that we do in scientometrics is activity measurement that proposes that counts of patents and papers provide valid indicators of R&D activity in the subject area of those patents and papers and at institutions from which they originate. Second is impact measurement, in which it is proposed that the number of times these patents and papers are cited in subsequent patents or papers provide valid indicators of the impact or importance of the cited patents and papers. The third is linkage measurement. It is proposed that citation from papers to papers, from patents to patents, and from patents to papers provide indicators of intellectual linkages. Application of bibliometric analysis. It can be under four levels: evaluation of national or regional technical performance, which is at the policy level; evaluation of scientific performance of universities or technological performance of a company at a strategic level; tracing of and tracking R&D activities in specific scientific and technological areas or problems, tactic level; and the fourth would be they identify specific activities and scientific people engaged in R&D, conventional level. Scientometric techniques. In terms of methodological perspective, scientometric techniques can be classified into two categories: one dimensional or scalar and two dimensional or relational techniques. One dimensional techniques are based on direct counts or occurrences and graphical representation of specific bibliometric entities. that is publications and patents, or particular data elements in these items such as citations, keywords, or addresses. Two-dimensional techniques are based on co-occurrences of specific data elements such as number of times the keywords, classification codes, citations, and addresses are mentioned together. Here we look at the science and technology performance indicators. We have categorized it under three categories for intellectual understanding. Publication output matrices. They include scholarly output, publications share, publications in top percentile journals, top percentile of the overall publication output in a field. Citation impact matrices includes indicators of citation count, citation per publication, H indices. For example, is a H index of 10 means. What does it mean? It means a scientist has H index H, that is H of his or her N, that is total papers, have at least H citations each, and the other, that means his total papers minus the number of papers that is in H have no more than H citations. This is a indicator which is now being increasingly used to measure the citation impact of a group or an individual. As citations differ field-wise, some fields like biology, genomics, medicine have high citations, and other fields like mathematics, astronomy have low citations. So we use field weighted citation impact to normalize the field so that a proper citation impact can be derived. Other indicators that we use are citation share of your group's publication or your national publication in a particular discipline or overall. And we also look at other indicator like collaboration impact, that papers which are done jointly, what is the impact of these papers in terms of citation, then the other papers of you or your group or the nation at large in a technological area, science technology area, or overall with respect to the papers which are non-collaborative. Linkage matrices include co-authorship, cross-country collaboration, and covert matrices. These indicators allow us to look at the linkages between the different elements. This will be discussed further in this module. In this table, we highlight some common publication-based indicators of productivity. First common indicator is the number of papers. It is based on the volume of paper produced by an entity. It is easy to retrieve but does not say anything about impact. Share of the number of papers can show share of different institutions in the overall publication profile of a country research group. Useful for getting relative assessment, however, does not inform about impact. Comparison of research output over the years show degree of contribution to the production of papers. It helps to capture the evolution of research output in different years, however, does not inform about impact. Activity in different fields shows intensity of scientific activity field-wise, subfield-wise, capture field-wise performance, but again it does not inform about impact. Co-author, co-institutional indicators captures international collaboration, national collaboration, departmental collaborations. It helps to show to what extent an analyzed unit cooperates with other units in the production of papers. Again, it does not inform about impact. In this, we discuss through table the some common publication based indicators of impact. Number of citations. It gives an indication of the scientific impact. However, it does not take into account the older articles usually are more cited and the citation rates vary between document types and subject areas. Citation per publication. It talks of total citation received with respect to total papers, gives an indication of the average citation impact. But the problem is that citation rates vary between document types and subject areas, which may give different indications and would make this indicator questionable. Citation received in the year of publication. It shows how fast papers made impact on the international community, show influence of the work, but the disadvantage can be of using these indicators is that due to topical area or addressing current debate, the citation received by a paper can be very high then another paper which may be very useful but it is not in a topical area or addressing current debate. Uncited papers. The number of papers which do not receive citation even once during the time period considered is a important indication of the quality of a paper, but it can be also due to few researchers or a novel idea which takes time to pick up. We further discuss some common publication based indicators of impact. Highly cited papers. Number of papers that received maximum citation during the research period are captured. Through this, advantage is that requires data from a comprehensive citation database which is available, but problem is that highly normalized citation score can be due to few highly cited articles. Journal impact factor used to measure the impact of scientific journals where paper is published. High impact factor journals are assumed to have high influence. But again, problem is that impact factor is field dependent because citations have strong variance field wise. Number of papers in top ranked journals helps to select journal according to a suitable criteria like impact factor of the journal. Does reflect the potential impact of paper, however, does not take the size of the analyzed time duration into account. In this, we are trying to identify conceptual connection among documents. Two common methods are bibliographic coupling and co-citation analysis. Bibliographic coupling. Articles with shared reference are identified. This method is called bibliographic coupling. It is assumed that articles that have very similar reference have strong intellectual connection. Co-citation analysis involves tracking pairs of papers that are cited together in these source articles. When the same pairs of papers are co-cited with other papers by many authors, cluster of research began to form. The co-cited or core paper in this cluster tend to share some common theme, theoretical or methodological or both. These indicators help to identify the research front key development in a field. Cohort analysis is another useful method to capture the intellectual connection in a field. Cohort analysis is a content analysis method that uses patterns of co-occurrences of pairs of items, words or noun phrases in text to identify the relationship between ideas. Cohort analysis is also very much similar to co-citation analysis. The only difference is that cohort analysis focuses on words in the documents rather than references. Method, the word or phrases that are important are identified and the relatedness between words is calculated based on co-occurrences. Finally, the words are clustered and documents are assigned to these words clusters. Here we are giving a summary table of what all can be done from publication analysis. Authors. Different indicators can be constructed using that. Number in a subject field, institution, country, growth, correlation with productivity, collaboration, co-authorship, associated networks, author in a subject. When we take origin as a variable, we can capture rates of production, size, growth by country, institution, language, subject correlation with economic and other indicators. When we take source as a variable, we can capture the growth dynamics of journal, life cycle of a research field, quantity, yield distribution, various distribution by subject, language, country. When we take contents as a variable, we can analyze text, distribution of words, phrases in various parts, subject analysis, and undertake co-word, co-linkage analysis also. When we take variable citation, we can capture citation indices, impact factors, undertake co-citation studies. Some other analysis possible are number of references in articles, number of citations in articles, bibliographic coupling, co-citations, author connection through citations, subject structure, identification, network maps, etc. In applying these bibliometric based indicators, we should also be aware of their methodological problems. By this proper understanding of the methodological problems, the indicators that we construct will be more reliable, robust, and acceptable. Some of the issues of bibliometric indicators are that they indicate quantity of output, quality measurement is problematic. Non-journal methods of communication are ignored. Publication practices vary across fields, which we must take care while applying these indicators. Choice of suitable inclusive database is always a problem. Undesirable publishing practices, artificially inflated number of co-authors, shorter papers can give results which will not be reliable. Papers represent only one output of laboratory based activity which we should be aware of. There are many other activities in the laboratory, including the actual translation into products or processes which are not captured through papers. Papers may have high citation due to varied reasons. Friends, in this module we have discussed science indicators. For understanding this concept of science indicators, we have talked of indicators in general. we have discussed what steps you have to take to construct indicators which are robust, which are reliable and which are valid. Then we have introduced scientometrics and talked about the different indicators which are generally constructed to measure the different aspects of scientific activity. We have also highlighted that how this makes us to understand the different facets of scientific research and becomes an useful tool for decision making, and also it allows us to understand how the research performance of a unit or a country at large. It is also possible, as we highlighted, that how these indicators allow us to look at the different linkages between university, between industries and university, and also between different co-authors. So in a sense, by applying these indicators properly, we demonstrated that it becomes a very useful tool for decision makers as well as research scholars to capture important facets of scientific activity and apply them as necessary for strengthening their research or strengthening the research process. But we should not forget that there are limitations of these indicators, which we have also highlighted in this module. We also argue that it is important to construct indicators that can address intersection of input and output indicators. For example, linking funding to performance indicators. These type of intersection will make these indicators more useful and more people will rely on these indicators. And if at your end you are constructing these indicators, your work will become more enriching and valuable. We have to understand always the limitations of indicators which are constructed in scientometrics based on publication and citation count, as the proper interpretation of results and limitations leads to wider acceptance of these indicators. There is an evidence to make claims that are questionable, which should be avoided. More we are careful with the construction of indicators, more we are looking at what are the dimensions which it is measuring, and we are able to make these methodological issues very a part, I would say, of your indicator construction. This whole process will become more valuable for the other people to accept your findings. Thank you.